In the next two examples, we want to take a look at some application problems where we're using polynomial functions to tackle real-world problems. In example 14, the number of women aged 16 years and older in a certain country's civilian labor force can be modeled by the given function, where W represents the total number of women in the civilian workforce and X years after 1900. We want to find the x-intercepts for this function. So to do that, we'll ask Symbolab to find all of the intercepts, but all we'll need will be the x-intercepts. For 0.0007 times x minus 26.939 cubed. We're only interested in the x-intercept again, so 26.939, comma 0. Keep in mind that x represents years after 1900, so we need to take that value and add 1900 to it. So this value actually represents the year 1926.939, which we'll round for any interpretation. So in part B, we're asked, in the year blank, there were blank women in the country's civilian workforce. So our x value is telling us the year. So 1926 will round up to 1927 because of that 0.9. So our intercept is telling us that in 1927 there were 0 because our function value W is equal to 0. There were 0 women in the country's civilian workforce. Then in part C, we're asked, as time goes on, the number of women in the civilian workforce in this country will increase or decrease because this is a specific degree polynomial and the leading coefficient is going to end up being either positive or negative. So to answer that question, we need to come back and look at our function W. We're not going to do all of the work to expand this out, but we can look at it very briefly. We know that we have this leading value out front of 0.0007. And if we started expanding what we have under that cube, the first value would be x cubed. And then we would end up with some other terms after that. That tells us that the highest power that we would have in our function would be x cubed. So the degree of our polynomial is 3. And our leading coefficient is positive. Based off of that, we know that the number of women in the civilian workforce will continue growing. Because this is a third degree polynomial. That's not written very well. This is a third degree polynomial with a leading coefficient that's positive. So as x increases, or as time passes, W of x will also be approaching positive infinity. In the last example, since 2000, voter registration in a particular country has been decreasing according to this given function, where V represents the total number of registered voters in millions, X years after 2000. We want to use Symbolab to find the x and y intercepts for this function. So with the last example, we only wanted the x-intercept. Now we'll be interested in both of those results. And we end up with a single x and a single y intercept. So our x-intercept will be 44.472, comma 0, and our y-intercept was 0, comma 268.6999. Now we're told in this case that x is the years after 2000, so we need to take that value in our x-intercept and add 2000 to it to get 2044.472. And then we need to take our value for v in our y-intercept and multiply it by 1 million, since that value is actually in millions, to get 268,699,900. Then we can interpret those values. This tells us that there were 268,699,900 people registered to vote in this country in the year 2000. And by the year 2045, there will be 0, since our value for v is 0 in our x-intercept, there will be 0 registered voters in the country. Then in part D, we want to find v of 32 and interpret that result. To do that, we'll input our function again. And evaluate it for x is equal to 32 to get a little over 6.2063. But keep in mind that value v is in millions, so we need to multiply that by 1 million to get 6,206,300, which tells us that there will be 6,206,300 registered voters in this country in the year 2032. Because that's our value of 32 plus 2000, or 32 years since the year 2000.